Now you know how to collect data for a psychological study, but what we need to do next is talk about what to do with those data. Statistics. We need to use both descriptive statistics and inferential statistics if we conduct a psychological study. And you need to know what these terms mean. So let's take descriptive statistics. Basically, descriptive statistics describe our data. That's all they do. If, for instance, I give a quiz to everybody in this course and I have a colleague who stops me in the hallway of the department, should I ever go there again, and they ask me how my class did on the first quiz, I could, without mentioning names because I don't want to violate any FERPA laws, but I could list hundreds of students' grades until my colleague just walks off out of boredom. That's not useful. I can use a descriptive statistic and say, well, on average, students earn this score. So descriptive statistics really just summarize or describe your data. Here's what most people did when they took my quiz. In contrast, inferential statistics allow you to make inferences about your data. For instance, if you did conduct that caffeine reaction time experiment, was the hypothesis that caffeine affects reaction time, was that hypothesis supported? You're making an inference there. So both descriptive statistics and inferential statistics are very important when you conduct research. When I describe my data, I might decide that I would like to use a graph or figure to allow people to see in a very quick moment what happened with my data collection. And many research studies involve frequency distributions as a way of presenting data. How many times did something occur? Frequency. So here you're looking at some hypothetical data. Again, it's weight and preteens. And along the vertical axis you have an F, which represents frequency, or how many. And along the horizontal axis you have weight in pounds ranging from 80 to 160. And I'm showing you what would happen, hypothetically, if I collected data about weight from many individuals in this age group. I would probably see what is called a normal or bell-shaped curve. And when you look at this curve, you see that the majority of people have weights in the middle, around 120 here, and that as you move to the extremes, lower weights and higher weights, you have fewer and fewer people, lower and lower frequencies. This normal or bell-shaped curve is very important in the field of psychology and controversial. We'll talk about intelligence later in the semester, and you'll see a little of the controversy regarding its use. But generally speaking, there are so many different variables I could examine in the world where plotting a frequency distribution results in this normal or bell-shaped curve. I could ask every one of you, how many books did you read last year? And I would find that there's some middle value that most people did, and that few people read very few, extremely few books, and very few people read extremely many books. I could ask you, how many chocolate bars did you eat last month? And some of us, not me probably, would be in the medium range. So that would be a high frequency in a frequency distribution. Some few number of people would have eaten very few chocolate bars, and then I'd probably be up there in the on the right side of the plot, and I, with a few other people, ate very many chocolate bars. So one way to describe your data, and a very useful way, is to plot it, and quite often frequency distributions like this one are used. As you look at the screen, you're going to see something about measures of central tendency. Don't worry about it. We'll be talking about central tendency in a moment, and I will not ask you a quiz question about this. But if you know something about statistics, you know what I'm saying in that box. As we work to describe our data, we ought to think about measures of central tendency. And there are three measures of central tendency that I want you to know: the mean, the median, and the mode. And I actually want you to be able to calculate each one of these. I suspect that many of you are already familiar with these, but let's do a review. The arithmetic mean is the average, and you calculate it by adding up all the scores and dividing by the number of scores. I'm sure you've done that before. The median is the middle score after the scores have all been put in order from lowest to highest. So let me give you a heads up. If you have a quiz question where you have to calculate the median, make sure that all the scores are in order from lowest to highest. Finally, we have the mode, and this one's easy. The mode is the most frequently occurring score in a set of numbers. Let's make sure you can calculate these measures of central tendency. Imagine that I give a quiz, and here are the test scores that people earned. One person earned a 10, another person earned a 10. There was a 20, a 20, a 20, a 25, 30, 35, 40, and 50. These are the points earned by 10 people taking my quiz. So you should be able to calculate the mean, the median, and mode, all three measures of central tendency. So how do you do this? For the mean, you add up all the scores and divide by the number of scores. So 10 and 10 is 20, and 20 is 40, 60, 80, 105, 135, 170, 210, 260. So my total for all these 10 scores is 260. Then you divide by 10, the number of scores, and you get 26 points. That's your mean. The median is the midpoint. So looking at these scores, they're already in order from lowest to highest, so I just have to find the middle one. And hey, that's an even number of scores. Now, if it were an odd number, say there were 11, I would just pick out the middle one. But now I have to find the midpoint, which is going to be between 20 and 25. The midpoint between 20 and 25 is 22.5. Or I could just take the two middle scores, 20 and 25, add them together and divide by 2. So that's the median, it's the midpoint. The easy one is the mode. The mode here is 20 points because there are 3 20s, and that's more than any other score appears. So at this point, you can calculate measures of central tendency, the mean, the median, and the mode. And you know those are measures of central tendency. So I typically ask students to kind of, in their heads, visually graph these data as a frequency distribution. And I think most students can do this, and they realize, hey, it's not a normal or bell-shaped curve. And, you know, Professor Boatwright said that most variables do take the form of a normal or bell-shaped curve. And the reason it doesn't here is that there are too few scores, that you need many, many more scores for the results to take the form of a normal curve. You know that measures of central tendency are descriptive statistics, and that they summarize what occurred in a research study. But they do not fully describe your data. You need more. So imagine that I do give a test in this class, and that every person in my class scores 75% on the test. There's literally no variability there. Everybody scores exactly the same. So someone could ask me, how did your class do on that last quiz? And I'll say, well, the mean was 75%. And that's not all the information I should share. I should also mention that the variability was very low. What normally happens when one gives a quiz is that there's more variability, that some people score very low, some people score very high, and probably most people score somewhere in the middle. So in order to more fully describe your data, you need at least one measure of variability. There are two measures of variability that I want you to know. The first is the range, and you're probably familiar with that. To calculate the range, and you might have to do this, just subtract the smallest score from the largest score. So the range is a measure of variability, but it's not really the most frequently used or the most useful measure of variability. More often, researchers use the standard deviation, and the standard deviation is also a measure of variability. I'm not going to ask you to calculate the standard deviation in a general psychology class. I'm really going to ask you to learn the definition. Learning the definition of a standard deviation is really giving you some idea of how it's calculated, but I'm not requiring you to do so. The standard deviation is the average deviation from the mean. So you can see this is a measure of variability. On average, how much does each score deviate or differ from the mean? And to literally calculate it this way, you would be taking each score and taking the difference from the mean and finding the average of those differences. But you can't really do that because you need to transform your data first. But okay, general psychology, what do you need to know? Standard deviation is a measure of variability, and it is defined as the average deviation from the mean. Okay, let's move on to inferential statistics, which allow you to make inferences about your data. If I conducted our caffeine experiment, I had a control group, I had an experimental group. The experimental group ingested caffeine, the control group did not. Instead, they received a placebo treatment. And then I have the mean score for the experimental group and the mean score for the control group. I want to compare those. My hypothesis is that ingestion of caffeine speeds up reaction time, that it would be much faster for the experimental group than the control group. But how do I know whether it's fast enough for me to be able to conclude that my hypothesis was supported? I would use inferential statistics in order to be able to make this inference. Think about it. If the mean reaction time, RT is reaction time, for the experimental group is similar to the mean reaction time for the control group, meaning they're not very different, we must accept the null hypothesis because our results could occur by chance. I could conduct this caffeine experiment over and over with different groups of people, and I probably would rarely see exactly the same reaction time for the different groups. It's going to differ by chance. And if my mean reaction times for the two groups are similar, not identical, but similar, I basically have to infer that the results were due to chance factors alone and that caffeine ingestion did not affect reaction time. When you're a researcher, this is a bummer. On the other hand, imagine that the mean reaction time for the experimental group is much faster than the mean reaction time for the control group. We have to ask, are they different enough for me to be able to say that the hypothesis was supported? This is a bit more than you need to know for general psychology, but there are numerous types of inferential statistical calculations that you might use. There are analysis of variance, sign tests, and so on, that literally allow you to determine if the results for the two groups are different enough. When the results of these statistical calculations show that the means for the two groups are significantly different, then we can reject the null hypothesis. And that is wonderful. Just how different do the two means have to be in order for the difference to be described as significant? Basically, if a researcher can statistically demonstrate that the results would have occurred fewer than 5 times out of 100 by chance alone, then the null hypothesis can be rejected. Or the means for the two groups were so different that they were unlikely to be due to chance, and if you were to actually conduct the experiment multiple times, fewer than 5 times out of 100, you would have gotten these results. But you don't have to conduct the experiment over and over and over. Instead, you can use inferential statistics, and they let you know how often out of 100 times you would have gotten these results. Again, I'm not going to ask you the names of inferential statistical tests. I'm not going to ask you to calculate any inferential statistical tests. What I do want you to know is the 0.05 significance level that's used in psychology. And I've already explained it, but I'll do it again. In psychology, we use a 0.05 significance level. Probability less than 0.05 or fewer than 5 times out of 100. And when our inferential statistical tests show that we've achieved that level of significance, we say the results are significant. And as scientists and psychologists, we don't use that word significant lightly. It means that we've used statistical calculations. It means that we have found that our results would have occurred fewer times than 5 out of 100 if we were to just conduct the study over and over again. So this is the significance level in psychology. You must know this. 0.05, p less than 0.05, probability less than 0.05. And this is actually one reason why psychology is sometimes called a soft science. Because in biology, physics, chemistry, other, quote, hard sciences, the significance level that is used is p less than 0.01, or you need to show that your results would have occurred by chance fewer than 1 out of 100 times. With behavior, there's going to be more variability, and so we use a slightly less rigorous significance value in psychology. However, most of the time when I've conducted research, and I'm not unusual, my significance levels have achieved 0.01 or 0.001, meaning that they're even less likely to occur by chance. So maybe we can think of psychologists as soft science. We do use a slightly less rigorous significance level, but I wouldn't personally describe it that way. For our purposes, what I want you to know is that P less than 0.05, that is our significance level.